Hello and welcome back to all Control Panel Innovation Seekers. My name is Jorge Olarte. I am application consultant for industrial control panels. It is an honor and a pleasure for me to be your speaker today. And today's topic, short-circuit currents in industrial control panels. Did you know that no matter where you are, it is obligatory to have a short-circuit capacity or rating on the labeling of the panel? Short-circuit currents have no country boundaries. They can happen anywhere, and no matter where the electrical equipment is installed, it must be designed and dimensioned for a fault-free operation under normal operating conditions. Additionally, it shall be protected against damaging effects, particularly in the event of a fault, in the event of a short-circuit fault. When talking about control panels, you often hear or mention IEC, UL, or even CSA standards. In IEC, it's the IEC 6204-1. For the US, it is the UL 508A. And in Canada, the CSA 22.2, number 286-17. These are the correct standards for industrial control panels. All of these standards tell you how the short-circuit capacity or the overall short-circuit of a control panel must be determined. According to IEC 6204, this can be done by tests, by application of design rules, or by calculation. The procedure can be based on the standard IEC 61439-1 or in other IEC technical reports. The most common procedure actually is according to 61439-1. The following methods can be used to verify the short-circuit withstand strength, either verification by testing or verification by comparison with a tested reference design. In the case of US standards, UL 508A is the only approved calculation method by the National Electrical Code, or NEC, to determine the overall SCCR value of an industrial control panel. And here, the detailed description and calculation method is in the supplement SB. Beside the calculation, test is always an option, even though this is not often used for industrial control panels, because this is time-consuming and costly. In Canada, the CSA 286, similar like UL 508A, bases the short-circuit current rating in test or default ratings. And here is where the type-tested combinations get really interesting and helps us save money and time. Every single product has been tested for different voltages and have their own short-circuit capacity. Let us make an example. When we talk about control panel, there are always some load feeders that operate motors in different ways, depending of course the application. We may have direct starters, soft starters, and even frequency drives. The issue here is that for branch components, the standard SCCR is relatively low. As you can see here, the standard SCCR value is only 5 kA for a contactor up to 50 horsepower or 37 kilowatts. And for terminal blocks, even 10 kilowatts. These values are often too little, in particular in industrial markets, to be the overall short-circuit current rating of the control panel. The most interesting, easiest, and practical method to increase the overall SCCR values or ratings of an industrial control panel is to use the high-capacity short-circuit current rated based in tested combinations. Let me show you how this works. These load feeders, as a combination of motor starter protector and contactor, have been tested for a high short-circuit capacity based in IEC standards and have been provided with technical values, for example, for 3RA21 with 150 kiloamps at 400 volts. These load feeders have also been tested according to North American UL and CSA standards, also as part of a tested combination. As you can see here, the values for the UL standard are 65 kiloamps at 480 volts. The goal is therefore the same, only the values differ depending on the standard requirements in various markets. As you can see, we have the standardized solution for various markets, but keep in mind that SCCRs will vary according to the product standard that we must comply at Siemens. This also happens for soft starters and frequency drives. They have been tested under different product standards, but also have tested combinations and have been tested for high capacity short circuit current ratings. Our soft starter 3RW5 has now the certificates under IEC and North American standards, meaning it can also be used for a global solution for various markets. The same happens with our Dynamics drives. Especially for this type of power electronic products, you can find the type of coordination test given even more advantages when selecting the devices and the application. A big way of saving time when selecting these load feeders is our TIA selection tool. Let me show you how it works. So you click and open the TIA selection tool. Here you can see the version we're working on. The software is fairly updated every 2 months. If you see any differences in the user interface or menus, just come back to us. Here you will click New Device, and here you will click in this menu Industrial Controls. In the upper part you will find the load feeder for configurations into IEC or UL. This means that the TIA selection tool will bring you a type tested combination in any of these standards. Let's go for the IEC. Click Configure. So let's select a direct starter, an unfused direct starter with a voltage of 400 volts. We go for power of 5.5 kilowatts. As you can see, current is automatically displayed. Then if we scroll down, we will select an overload protection without or with none. Coordination type 1 or 2, we go for 1 in this example. And type of control supply, we go for AC of 230 volts. Now we need to select connection type, where we can find a spring type or screw type. We go for screw type. And then automatically the result tab pops up. In the result we can see we have a circuit breaker and a contactor, and the details of the certificates are under them. If we click here, you will be prompted to Siemens Industry Online Support, where you can be able to see the certificates. After you download it, you can see the type tested certificate for this. And in the section that I have marked, you see that this contactor 3RT2017 has been tested with a 3RV21, which up to here gives us 150 kiloamps as was shown. Remember that this cannot be changed. This is a type tested combination and no products can be changed then. In the case of selecting UL configurator, you also have to click Configure. And let's make an example just as we did. I have made my complete selection, and as you can see, the result tab pops up. When you click on it, the motor circuit breaker and contactor are also displayed. And here you will also be able to find the certificates under Siemens Industry Online Support. When downloading the UL certificate of the contactor, you will be able also to find the high short circuit current ratings. When you find this table, you will be able to see that the contactor we have selected with the combination motor controller 3RV21 actually has a range up to 16 amperes, where I can have a short circuit capacity of 65 kiloamps, like shown here. IEC certificate has a proven combination and possibility. This cannot be changed. If a different product is used, the short circuit capacity is not the same. If we do the same example for UL and get a combination in a similar way, the certificates tells us that we have a range of products that can be used. So there you have it, easy handling tool for product selection, type-tested combination tests that help us increase the SCCR by tests that we have done, and even save you time and money. Always with the correct documentation to support your offers and solutions. That is engineering efficiency. If you want to know more about this or more topics regarding industrial control panels, our main global website that you see here, siemens.com/control panel, provides you assets, reference manuals, white papers, video tutorials, web-based trainings, software tools, and many other things. It is all about electrical engineering for industrial machinery and industrial control panels. We invite you to visit it. Thank you all, and stay tuned for the series of videos.